All right, let's look a little closer at how q equal to ab to the t is related to our continuous growth function. Q is equal to ae to the kt. Okay, we know that k is our continuous growth rate, and we also know that b is equal to e to the k. So if we want to get away from the continuous growth rate and find out the annual growth rate, so how much maybe our deposit has grown or the population has grown or how much something has decayed when it had a continuous change rate, to get to our annual growth rate, we're going to take e to the k and subtract 1, which is really the same as saying b minus 1, which is equal to r, which is that thing that we were finding back in section 4.1. Okay, so these ideas all kind of loop together here. What we're going to look at in numbers 10 through 13 is we're going to identify that continuous growth rate k, and then we'll find the annual growth rate and kind of see how those compare. All right, so my k here in number 10, p is equal to 5e to the 0.02t. My k is 0.02 or 2%. And my annual growth rate here is equal to e to the 0.02, that whole quantity, and subtract 1. That gives me approximately 0.0202 or 2.02%. So pretty close, but slightly different. And the reason we get a slightly different number here is that this continuous growth rate, we're compounding upon compounding upon compounding. So we're getting interest on the interest on the interest. Okay, so this number is a little more succinct, whereas here, when we're looking at just what is the overall at the end of the year, how did this grow or change, we're getting this 2.02%. So that's totally expected that those are going to be different numbers there. Generally not too terribly different, but different. Right, number 11, q is equal to 4e to the negative 0.075t. So my k here is negative 0.075 or negative 7.5%. My annual growth rate is e to the negative 0.075, that whole quantity minus 1, which is approximately negative 0.072 or negative 7.2%. Okay, so again, fairly close here. Number 12 and 13 and 14, I'm going to have you pause the video and try those on your own. But before you do, I want to talk about 12 really quick. So r is equal to 3e to the negative 1.25t. So my k here is negative 1.25, which is really negative 125%. Okay, so whereas these ones were like 2%, 7%, this is 125%. Okay, so the difference between this and the AGR is going to be a little bit bigger. Okay, so don't panic if you get something around the 70% mark. You're totally in the right place. But go ahead and pause the video, try those next 3 problems, and we'll come back and do them together and make sure we get to the same place. All right, so hopefully you gave those a try. Number 12, we did already discuss, that was a negative 125%. Our annual growth rate here is e to the negative 1.25 minus 1, which is approximately negative 0.713 or negative 71.3%. So definitely a bigger difference there, but that has to do with the relative size of our continuous growth rate there. Number 13, t is equal to 2e to the 0.31t. So k is 0.31 or 31%. And our annual growth rate here is e to the 0.31 minus 1, which gave me approximately 0.363 or 36.3%. All right, number 14, an investment has a yield equivalent to 2.323% continuous yearly rate. We want to find that effective annual rate. So we're going to do e to the 0.02323 minus 1. When I crunch that in my calculator, I get approximately 0.0235 or 2.35%. All right, so that is our annual growth rate.